Okay, so good day everyone. Our topic for today is about organization and presentation of data. Data gathered can be made more interesting and organized by presenting them in the form of graphs in tables. Readers may not appreciate reading a statistical report on the current population of different countries in the world if the report is just a list of numbers from one paragraph to another. The different types of data in the various ways of collecting them were presented. So the different sampling methods were also discussed. No? So in this lesson, you will learn how to present the data in tabular or graphical forms. The tabular the tabulated textual form of presenting data will no longer be discussed. The data types are the frequency distribution, correlated data, and time series data. There is no need to conduct the frequency distribution table if the number of observation is less than 30. Again, there is no need to construct the frequency distribution table if the number of observation is less than 30. Data that are presented in a frequency distribution table are called group data, while those that are not are called ungrouped data. Okay, so again, this topic is under lesson 3 for the probability in statistics. So, what is research data? So, research data is any information that has been collected, observed, generated, or created to validate original research findings. Although usually digital research data includes non-digital formats such as laboratory notebooks and diaries. So, as what we have here, we have types of research data. We have a document spreadsheets, laboratory notebooks, field notebooks, diaries, questionnaires, transcripts, code books, audio tapes, video tapes, photographs, films, and of course, the test responses. We have also slides, artifacts, no? Specimens and samples, specimen samples. We have collections of digital outputs, of course, data files, database contents like video, audio, text images, models, algorithm scripts, content of an application like input, output, log files for analysis, software, simulation software, and schema. So, okay. So when it comes to non-digital data such as laboratory notebooks, I-score samples, and sketchbooks are often unique. You should assess the long-term value of any non-digital data and plan how you will describe and retain them. You could digitize the materials, but this may not be possible for all types of data. So we have the sources of data. So research data can be generated for different purposes and through different processes. So we have observational data, experimental data, simulation data, derived or compiled data, and reference or canonical data. The presentation of data. It is the utter importance nowadays. So after all, everything that is pleasing to our eyes never fails to grab our attention. Presentation of data refers to an exhibitions or putting up data in an attractive and useful manner such it can be easily interpreted. The three main forms of presentation of data are textual presentation, of course, data tables, and diagrammatic presentation. So when it comes to textual presentation, Of course, this kind of presentation is useful when we are looking to supplement qualitative statements with some data. So, it's just to have a statement that serve as a fitting evidence to our qualitative or quantitative evidence and helps the reader to get an idea to scale the phenomenon. So for example, no, so the 2002 earthquake proved to be a mass murderer of humans, as many of 10,000 citizens have been reported dead. So therefore, the textual representation of data simply requires some intensive reading. And this is because the quantitative statement just serves as an evidence of the qualitative statements, and one must go through the entire text before concluding anything. So, if the data under consideration is large, then the text matter increases substantially. As a result, the reading process becomes more intensive, time-consuming, and cumbersome. So, data tables or tabular presentation. A table facilitates representation of even large amounts of data in an attractive, easy to read, and organized manner. So the data is organized in rows and columns, and this is one of the most widely used forms of presentation of data, since data tables are easy to construct and read. So when we say row, that is horizontal. When we say columns, that is vertical. So the components of the data table, of course, we need to have a table number. Okay? Title, of course. It must be contain a title that clearly tells the readers about the data. It contains time of period of study, place of study, and the nature of classification of data. Head notes, of course. Head notes present the units of data in brackets at the end of the table title. Then the stubs, no? These are the titles of the rows and the tables in the table. Okay, and of course, we have also a caption, no? Wherein the title of the column in the data table. So it is a counterpart if a stub and indicates the information contained in a column. Then body field, of course. The body of a table is in content of a table in its entirety. Each item in a body is known as a cell. So, actually in Microsoft Excel, that is what we call active cell. A combination of a row and column. Of course, another component, footnotes. Footnotes are rarely used. So, in effect, they supplement the title of a table if required. Then we have source, no? So when using data obtained from a secondary source, this source has to be mentioned below the footnote. Construction of data table. So there are many ways of construction of a good table. However, some basic ideas are the title should be in accordance with the objective of the study, the comparison, alternative location of stubs, headings, the footnote, of course, and size of columns wherein it must be uniform and symmetrical. Use of abbreviation, headings and subheadings should be free of abbreviation, no, for the readers to understand the exact terms, no, that we indicated in our headings. Units, there should be a clear specification of units above the column. So we need to specify clearly the units. Now, what are the advantages of the tabular presentation? Of course, number one is of representation. So, a large amount of data can be easily confined in a data table. So it is a simplest form of data presentation. Use of analysis, no? Used for statistical analysis like calculation of central tendency or dispersion and others. Helps in comparison. So the rows in columns which are required to be compared can be placed next to each other. So to point out, this facilitates comparison as it becomes easy to compare its value and economical. Okay? So the data in a manner which is really easy on the eyes of a reader. It saves time as well as space. Okay, so classification of data in tabular presentation. So we have qualitative classification. So data in a table is classified on the basis of qualitative attributes. So in other words, if the data contain attributes that cannot be quantified like rural, urban, boys, girls, and others, it can be identified as a qualitative classification of data. So based on what we have here. Then the quantitative classification, data is classified on basis of quantitative attributes like marks, the 0 to 50, no? So as what we have here. So for example, that is 0 to 50, that is 29 number of students. For 51 to 100, for example, we have 64 number of students. Then we have also what we call temporal classification. When the data is mentioned with respect to different time frames, we term such as classification as temporal. So, for example, as what we have here by 2016, no? So, we have 10,000 sales. In 2017, we had 12,500 sales. And that is an example of a temporal classification. How about the spatial classification? When the data is classified according to a location, it becomes a spatial classification. So, for example, we have a country and number of teachers here. As presented, no? So, we have 139,000 for India and 43,000 for Russia. Now, the difference between group data and ungroup data. So, maybe you're asking, what is group data and ungroup data? The word data refers to information that is collected and recorded. It can be in the form of numbers, words, measurement, and much more. Again, there are two types of data, and these are qualitative data and quantitative data. The difference between the two types of data is the quantitative data is used to describe numerical information. For instance, the measurement of temperature would fall under this kind of data. On the other hand, qualitative data is used to describe information in words after collecting data. It needs to be organized, hence the need to separate group data from ungroup data. But both are useful forms of data, but the difference between them is that ungrouped data is a raw data. No? This means that it has just been collected but not sorted into many or into any group or classes. Group data is data that has been organized into groups from the raw data. Okay, so this will be a group data. So it is the type of data which is classified into groups after collection. Okay? So for example, when a test is done, the results are the data in this scenario, and there are many ways to group this data. So the number of students that scored above each 20 mark can be recorded. So as what we have here, the grades can be used, for example, a 90 to 100 all the way to 0 to 59. So with each category showing how many students are in each category. So histogram and frequency table are best used to show and interpret group data. So here is the example. of a histogram of data. So range size is equal to 25. So 1 to 26, 26 to 650, 21 to 56, and so on. So, grouping of data has the following advantages, no? Helps improving the efficiency of estimations. It allows for greater balancing of statistical power of test of the difference between strata by analyzing equal number from strata. Irrelevant subpopulations are ignored while the significant ones are on focus. So, what is ungrouped data? Actually, it is also known as raw data. So, data that has not been placed in any group or category after collection. So, the number of individuals residing in that area is ungrouped data or raw information because nothing has been categorized. We can therefore conclude that ungrouped data is data used to show information on an individual member of a sample population. So, what are the Okay, some of the advantages of ungrouped data are as follow. Most people can easily interpret it. When the sample size is small, it is easy to calculate the mean, mode, and median. So it does not require technical expertise to analyze it. Okay? The classification of group data versus ungrouped data. The group data is data that has been organized in classes after its analysis. So example include how many bags of maize collected during the rainy season were bad. On the other hand, ungrouped data is data which does not fall in any group. It is still a raw data. The preference of group data versus ungrouped data. When collecting data, ungrouped data is preferred because the information is still in its original form. It has not been tampered with classification or subdivision. However, when analyzing it in drawing graphs, group data is preferred because it is simple to interpret. Accuracy. Of course, when calculating the means of group and ungrouped data, there will be a variation. The mean of group data is preferred because it is more accurate as compared to the mean of ungrouped data. The mean of ungrouped data may lead to wrong manipulation of the median. Therefore, it is considered inefficient in most cases. For representation, frequency tables are used to show the information of group data, whereas in the case of ungrouped data, the information appears like a big list of numbers, and this is due to the fact that the information is still raw. So this will be the table of group data versus ungrouped data. So you could able to see the differences, group and ungroup, classification, preferences, accuracy, presentation, and of course, the summary. So, of course, in statistics, the term data is used to refer to information that has been collected and recorded to the purpose of specific projects, and it could be either qualitative or quantitative. So, frequency distribution. So, a graph or data sets organized to show the frequency of occurrence of each possible outcome to a repeatable event observed many times. Frequency distribution can be graphed as a histogram or pie chart. So, for large data sets, the step graph of a histogram is often approximated by the smooth curve of a distribution function or called a density functions when normalized so that the area under the curve is 1. The So the most convenient way of organizing data is by constructing a frequency distribution, of course. Because a frequency distribution is a collection of observation produced by sorting them into classes, ensuring their frequency or numbers of occurrence in each class. And actually we have three basic types, no, of frequency distribution. We have categorical, ungrouped, and of course the group. So this will be the steps, no? The most important, you need to find the range, no? Of course, R using the formula. So R is equal to highest score deducted to lowest score. Then compute for the number of intervals N by using the formula. N is equal to 1 plus 3.3 log N. So where lowercase n is the number of class intervals, uppercase N a population or total number of observations. Then compute for the class size I using the formula I is equal to R over N. Using the lowest score as lower limit, add I is minus 1 to it to obtain the higher limit of the desired class interval. So the lower limit of the second interval may be obtained by adding the class size to the lower limit of the first interval. So add I is equal to 1 to the result to obtain the higher limit of the second interval. You may repeat the step 5 to obtain the third class interval and so on and so forth. So, when the n class interval are completed, determine the frequency of each class interval by counting the elements. Number 1, construct the frequency distribution table of the data below. So, as what we have here, so age of the COVID-19 patients in CVY hospital, for example, in January 2021. So, we have given a number, no? So, that is of the COVID-19 patient in CBY hospital. Okay? So, step 1, okay? So, as what we have earlier, you need to find the highest lowest score to highest score to and lowest score. Then, as what, based on the given example earlier, we have 60 as the highest and 6 as the lowest. So, 60 minus 6 is equal to 54. Step 2, compute for the number of intervals. So, n is equal to 1 plus 3.3 log 36. Why 36? Because the given data a while ago, or given occurrence actually a while ago is equal to 36. That is n is equal to 6. Compute for the class size I is equal to 54 divide 6. Because we have the range 54 and our n is 6. So, for us to get the class interval, of course, the class size I is equal to range minus n. Okay, so therefore the answer is 9. Now, since the lowest score is 6, this becomes the lower limit of the first class interval. The higher limit of this interval is 14, which is obtained by adding 9 minus 1 or 8 to 6. Because 9 minus 1 is 8. Then, a while ago, our lowest score is 6. So, the lower limit of the second interval is obtained by adding 9 to 6, and the higher limit by adding 8 to the result. 6 plus 9 is equal to 15. So, 15 plus 8 is equal to 23. So, the lower and upper limits of the third interval and the next intervals are obtained using the same steps or procedures. So, tally marks are used to aid in counting the elements of each interval. Then, the corresponding frequencies are obtained by counting these tally marks. The total frequency must tally with uppercase n, and the total number of observations. So, the high score is not included in the sixth interval. Consequently, it is necessary to add one more interval. So, age of patient a while ago. So, as we presented the occurrence a while ago. So, as I mentioned, we started from 6 because our lower score is 6. Then, a while ago, we have 8 plus 6, that is 14. That's why 6 to 14. and so on and so forth, up to 60 to 66. Now, so if we count how many numbers or occurrence fall in 60 to 66, that is 1. For 51 to 59, that is 2. 42 to 50 is 3, and so on and so forth. The N is 36 as what I mentioned earlier. Okay, so example number 2. So the following data given by the result of a sample survey of Techbook track students in Holy Face of Jesus, Lyceum of San Jose Incorporated. The letters A, B, C represent the categories. So solution. So how many A's, how many B's, and how many C's? Total number is 30. So 6 A's, 9 B's, and 15 C's. If we're going to tally the given letters presented in table 4 a while ago. Okay, so making a frequency distribution and histogram. To show you how to do this, we will be using the data set below. So we went ahead and put the numbers in order, which will make everything much easier. So, okay. So steps to making your frequency distribution. Calculate the range of the data set. So range is equal to 65, the highest score. Then the lowest score is 12. So 65 minus 12, that is 53. Divide the range by number of each group you want and then round off. So let us say that we choose to have 6 groups. So if we do this then, 53 divided 6, that is 8.8. So again, we will round this up to 9 just because it is easier to work with that way. Okay? In general, people who are doing this by hand always round up even if it was 8.1. Okay? So steps to making your frequency distribution is use the class width to create your group. So we are going to start at the smallest number we have, which is 12. Diba? As what we did a while ago. And count by 9. So 12 plus 9, that is 21. Until we have 6 groups. So as what we have here. So this will be the first group, second group, third, fourth, 5, and 6 groups. Okay, so table number 7. So that last table is our frequency distribution. To make a histogram from this, we will use the groups of the horizontal axis and the frequency on the vertical axis. And we will use bars to represent the frequency of each individual group. So with this data, the finished histogram will look like the one below. So this will be the histogram data of data. Okay, so how about class marks? So the class midpoint, no, or class mark is a specific point in the center of the bins or categories in a frequency distribution table. It is also center of a bar in a histogram. It is defined as the average of the upper and lower class limits. The lower class limit is the lowest value in a bin, a particular category. Then the upper class limits are the highest values that can be in the bin also. All members of the class are represented by their class marks when calculating most statistics for a frequency distribution table. In calculating the midpoint, you need to know the class limits for your data in order to calculate the midpoint. If you do not know how to find class limits, okay, see the steps in how to make a frequency distribution table a while ago. So this will be an example. Find the midpoint for class limits of 182 and 199. So the average of the class limit is 180 plus 199 divided 2. That is 89.5. This is your midpoint. Okay, you might see the class mark defined as the average of the class boundaries as well. And you will get the same results. So the same bin might have class boundaries of 179.5, 199.5, giving the 1.79.5 plus 199.5 is equal to 189.5 also. Okay? What if I have open-ended classes? So, Again, as what we have here, it is a midpoint of a class interval. So to obtain this point, add the lower limit and upper limit, then divide by the sum of 2. So in our table number 3 a while ago, ages of patient in CBY hospital, for instance, the class mark of the interval will be as follows. So 51 to 59, that is 51 plus 59 divide 2. So therefore the answer is how? Then 60 to 69, of course. Okay, so 60 plus 68 over 2 is equal to 64. While 51 to 59 is 51 plus 59 divide 2 is equal to 55. So frequency distribution of the patient. So 60 to 66 is 1. 51 to 59 is 2, class marks, and so on and so forth. So how about the class boundaries? So the class boundaries are the data values which separate classes. They are not part of the classes or the data sets. So as what we have here, no? So there are also known as exact limits and can be obtained by subtracting 0.5 from the lower limit. So as you can see here, if we have 60, no? 60 here. So in lower class, minus 0.5 is 59.5. In the upper class, plus 0.5. So 66 plus 0.5, that is 66.5, no? And so on. So for 51, that is 50.5. For 59, that is 59.5. Up to 6, that is 5.5 minus 0.5, of course. Then 14.5 for 14. That is plus 0.5. Again, lower class boundaries minus 0.5. Upper class boundaries plus 0.5. Number 3, when 40 students were surveyed at Holy Face of Jesus, they reported the distance they drove to the school. So in the results in kilometers are given below. So solution, follow the steps. The number of classes is 8. Then range is equal to highest minus lowest, that's 40 minus 1 is equal to 39. Class width is range divide classes, that is 39 divide 8, that is 4.875 or 5. Determine the lower limit, subtract 1 unit from the lower class, limit and second class to obtain the upper limit of the first class. So 6 minus 1 equals 5. So then add the class width to the get succeeding upper class limit. So 1 to 5, so 6 to 10, 11, 15, up to 36 to 40. Ay, ito. So we determine the class boundaries, okay? So 1 is 0.5, that is class boundary, so lower limit and upper limit, no? So minus 0.5 to the lower limit and plus 0.5 into the upper limit. Okay, so total the scores or tally the scores. So as what we have here, no? So the tally marks, no? So we count. So make the frequency distribution table. So we have the frequency, how many numbers from 1 to 5, that is 11, 6 to 10, that is 9, and so on and so forth. Okay, so a variation of the standard frequency table is used when cumulative totals are desired. So the cumulative frequency for a table whose classes are increasing order in the sum of the frequency for that class and all previous classes. So how to get the cumulative frequency? So as what we have here, so 11, that is 11. Frequency 11 is cumulative frequency 11. Then 11 plus 9, that is 20. 20 plus 6, that is 26. 26 plus 5, that is 31. 31 plus 6, that is 37. 37 plus 0 equal to 37. 37 plus 2, 39. 39 plus 1 is equal to 40. That is the way on how we'll be able to get the cumulative frequency. Okay? So, correlated data. The correlated set of data is a table where two or more frequencies are shown for easy comparison. If one wants to compare the number of cases according to age, then total frequency will be the sum of the frequencies of the male and female patients per each group. A new table may be formed as follow. So, for example, based on the given example a while ago, no, on our age of patient in CVY Hospital in January 2021. So, for example, age 60 to 66, 1 female and 0 male. So, therefore, the total frequency is 1. 51 to 59 years old, that is 1 male, 1 female. That is the total frequency of 2. For 40 to 50, 1 male, 2 female, that is a total frequency of 3. 33 to 41 years old, 2 male, 0 female, that is 2, the total frequency. 24 to 32, that is 13 for male, 7 for female, that is 20, and so on and so forth. So as you can see here, we have a total of male that is 19, a female that is 17, and the total frequency is 36. So, in this table, the data are grouped according to religion and sex. So, one can say that 70% of the male and 60% of female in the distribution belong the region A, and 30% of the male and 40% of female in the distribution belong to a region B group. Okay? So, as what we have here. Okay, so, how about the time series? So, this is opposed to cross-sectional data which observed individuals, companies, and others at a single point in time. The statistical characteristic of time series data violate the assumption of conventional statistical methods. So, because of this, analyzing time series data requires a unique set of tools and methods. So, what is the example of time series data? So, as what we have here for economics, social science, epidemiology, medicine, and physical sciences. So, the time series data is collection of quantities that are assembled over even intervals in time in order chronologically. The time interval at which data is collection is generally referred to as the time series frequency. So, the time series graph above plot the visitors per month to Yellowstone National Park with average monthly temperature. So, the data ranges between January 2014 to December 2016 and is collected at a monthly frequency. So, this will be the time series visualizations. So, as you can see here, that is by year, no? So, what is a time series graph? So, time series graphs plots observe values on the y-axis against an increment of time on the x-axis. These graphs visually highlight the behavior and patterns of the data and can lay the foundation of building a reliable model. So, visualizing time series data provides a preliminary tool for detecting if data is mean reverting or has explosive behavior, has a time trend, exhibits seasonality, and demonstrate structural breaks. So, in addition to containing a non-zero mean, time series data may also have a deterministic component that is proportionate to the time period. While seasonality is another characteristic of time series of data that can be visually identified in time series plots. Seasonally occurs when time series data exhibit regular and predictable patterns at time interval that are smaller than a year. So, an example of a time series with seasonality is retail sales, which often increase between September to December and will decrease between January and February. So, structural breaks. Sometimes time series data shows a sudden change in behavior of a certain point in time. So, as what we have here, no? So, in 1980, then going up, no? 1990 up to 2010. So, the time domain versus frequency domain model. So, two broad approaches have developed for modeling time series data. The time domain approach model future values as a functions to past values and present values. So, frequency domain models are based on the idea that time series can be represented as function of time using sines and cosines. So, this will be an example of time domain and the frequency domain examples. Unvariate versus multivariate time series model. So, the time series models may also be split into univariate time series models and multivariate time series models. The univariate time series models are models used when the dependent variable is a single time series, trying to model an individual's heart rate per minute using only past observation of heart rate and exogenous variables. Okay, so multivariate time series models are used when there are multiple dependent variables. So example, as what we have here, the data shows the change of variable over a period of time. An example is the annual population growth rate in a certain place, such as the data in table 20. So as what we have here. So it clearly one can say that the population continuously increased from year 1 to 9, and the appropriate graph for a time series data is a line graph. So this will be a sample line graph for the population of a region B. Types of graphs in statistics. So the type of graphs in charts, we have statistical, exponential, logarithmic, trigonometric, and frequency distribution. So the statistical graph or chart is defined as a pictorial representation of statistical data in graphical form. The statistical graphs are used to represent a set of data to make it easier to understand and interpret statistical information. The different types of graphs that are commonly used in statistics are here, no? So this will be, we have a bar graphs, no? Pictorial representation of data in the form of vertical or horizontal rectangular bars, where the length of bars are proportional to the measure of data. So, okay, so type of bar chart. So if the length of the bar graph is more, then the values are greater of any given data. So we have vertical and horizontal. When it comes to the vertical and horizontal, the two different types of bar chart are group bar and stack bar. So we have four different types of bar graphs. So vertical bar graphs, when the group data are represented vertically in a graph or chart with the help of bars, where the bars denote the measure of data, such as graphs, are called vertical bar graphs. The data is represented along the y-axis of the graph, and the height of the bars shows the values. While the horizontal bar graphs, when the group data are represented horizontally in the chart with the help of bars. Group bar chart, or called the clustered bar graph, which is used to represent the discrete value for more than one object that shares the same category. Stack bar graph is also called the composite bar graph, which divides the aggregate into different parts. Uses of bar graphs: it is used to match things between different groups or to trace changes over time. A bar chart possesses a discrete domain of division and more normally scaled so that all the data can fit on the graph. No? When there is no regular order of the division being matched, bars on the chart may be organized in any order. Bar charts organized from the highest to the lowest number are called Pareto graphs. So, example of a bar graph. So, to understand the above types of bar graphs, consider the following examples. So, savings and number of employees. So, this will be the bar graph. So, as what we have here, this will be the number of students, no? And then this will be the savings percentage. So, another example, of course, bar graph. Same given data, but different graphs, no? It is also another way around. So the variation of temperature in the region during a year is given as follows. So defect it through the graph bar. So temperature, as you can see here, and then the month. So this will be the temperature at the lower part, no? This one, no? And this one will be the month, no? So from January to December. Histogram. This is a graph that displays the data by using vertical bars, no? To represent the frequencies. To draw a histogram, first mark the class on the horizontal axis and frequencies on the vertical axis. Draw a bar for each class so that its heights represent the frequency of that class. So the bars are drawn adjacent to each other. The frequency polygon, this graph display the data by using lines that connect points plotted for the frequency of the midpoints of the classes. And to draw the frequency polygon, mark a dot above the midpoint of each class at a height equal to the frequency of that class. Then mark two or more classes, one at each end, and mark their midpoints. OGIV, no? This is a graph that represents the cumulative frequency of all classes. So to draw an OGIV, mark the class boundaries on the horizontal axis and the cumulative frequency on the vertical axis. Plot the cumulative frequencies at each upper class boundaries. No? Upper class boundaries are used since the cumulative frequencies represent the number of observation accumulated up to the upper boundary of each class. So, thank you, and this will be our references. Thank you and good day, everyone. Good luck and see you to our next topic.